Hi class, in this recording we're going to talk about things that influence the ability to unload oxygen from the blood hemoglobin, I should say. So as we look at these four factors, we're going to talk about how we can fudge the ability to store oxygen or get rid of oxygen from hemoglobin. Our hemoglobin within our body needs to get oxygen to the tissues based on the metabolic needs of those tissues. So let's first look at ambient oxygen, partial oxygen. The less oxygen a tissue has, so as partial pressures of oxygen goes down, the more oxygen that we get rid of. So as ambient oxygen goes down, the more likely we are to release oxygen from hemoglobin. And that's why we have this classic curve right here. So that as oxygen levels go down, let me clear the graphs, as we have less oxygen, partial pressure of oxygen goes down, going down towards the origin, we have more and more oxygen unloaded from the hemoglobin. The oxygenation rate of the hemoglobin goes down based on a percentage. Something else that is important is the blood pH, and this is known as the Bohr effect. As we have more carbon dioxide buildup in the blood, we'll have more hydrogen ions. And as we have more hydrogen ions, the pH becomes more acidic or lower. And the lower the blood pH, the more we're going to unload oxygen from our hemoglobin. So if we have a blood pH of 7.2, which is more acidic than 7.6, the curve here becomes a shallower curve, and we're more likely to unload oxygen from our hemoglobin compared to up here where we have the steeper curve at the more alkaline pH. Something else that we need to look at is body temperature. Normal body temperature is represented by this blue line. An increase in body temperature, so a fever state, is going to increase unloading of oxygen. So as our body temperature goes up, the rate of unloading oxygen also is going to go up as well. And conversely, if body temperature goes down, we tend to hang on to oxygen in our blood for a longer period of time. So you probably heard stories about children, small children who fall into the ice when they were ice fishing or playing on a lake during the middle of winter, and how after being underwater for 15 or 20 minutes, they can be revived. One of the things that contributes to that is the lowering of their body temperature, which causes their oxygen to remain in their circulation, within circulation for a longer period of time while they have lower metabolic needs of that oxygen. Something else that we should talk about is bisphosphoglycerate, BFG. Bisphosphoglycerate is a chemical compound that's going to be produced by our red blood cells that can bind to hemoglobin. And as bisphosphoglycerate binds to hemoglobin, it's going to cause oxygen to be unloaded. So if we have, and here we can see a figure here illustrating this, we have a hemoglobin molecule without bisphosphoglycerate with lots of little green oxygens attached. But if we take bisphosphoglycerate, 2,3-bisphosphoglycerate, and put it in the center of that hemoglobin molecule, that's going to cause the hemoglobin molecule to change shape so that it unloads oxygen molecules. What causes us to have more bisphosphoglycerate in our red blood cells? We have more bisphosphoglycerate if we have an increase in body temperature, if we have an increase in thyroxine, human growth hormone, blood testosterone, and epinephrine. Those could all raise bisphosphoglycerate levels and make it so that we're more likely to unload oxygen. So here's a figure that brings it all together. If blood pH goes down, bisphosphorylates go up, and temperature goes up, we deliver more oxygen to the blood. And then up here, if pH goes up, body temperature goes down, and bisphosphoglycerate goes down, we have less oxygen going to the bloodstream. So this is kind of a complicated topic, so I'm sticking to just 3 slides for this recording. If you have any questions or comments, please feel free to post them in the class discussion boards or to shoot me an email. And as always, happy studies.